This is part 3 of section 7.5. Okay, in work with electric circuits, the formula 1 over A is equal to 1 over B plus 1 over C occurs. Find B if A equals 8 and C equals 12. So they want us just to plug in these values and solve for B. So 1 over A would be 1 over 8 is equal to 1 over B plus 1 over C, which is 1 over 12. Okay, so if I wanted to, I can move the 1/12 over here. I could deal with my fractions and get my answer pretty quickly. Or I can find the LCD and multiply everything by that. My LCD is definitely going to have a B in it. And with the 8 and the 12, 8 does not divide into 12, but 8 does go into 24, and so does 12. So 24B. I'm going to multiply everything here by 24B, and that's over 1. So if I multiply these two, the 8 cancels with the 24 to give me a 3, and I'm multiplying by 1, so that's going to be 3B is equal to, here my B's will cancel out, so I get 24, okay, plus the 12 and the 24 reduced to a 2, so it's going to be 2B. Okay, now subtract 2B from both sides, and you get 1B is equal to 24. Now we're not given any kind of units on here, so your answer here is just 24. Now you might be wondering if on these problems you're always going to get the number part of your least common denominator, because we did here and we did here as well. But no, that doesn't always happen. It would be so nice if it did, but it doesn't. Okay, so the last type of problem are these types where we have a formula and we are asked to solve for a variable. We've worked these types before, we just have fractions in them this time. Okay, so if I have you want to be really careful with your capital letters too, because as you can see here, we have a capital M and a lowercase m. They would stand for different things in the formula. And when you enter it in MyMathLab, if you use the wrong case of your letter, it's definitely going to count it wrong. So here I want to get capital M by itself. Okay, so this is over 1 right here. I have one fraction equal to another. So what I'm going to do is I'm going to cross multiply. So I'm going to have F times D squared is equal to 1 times this, and multiplying by 1 doesn't change the numerator at all. So this is what I have right here. Now all of these are multiplications, and to undo multiplications we divide. So to get this capital M by itself, I would need to divide by a capital G and a lowercase m. And if I do that over here, I need to do that over here as well. Now, what happens is these cancel out and these cancel out, and we have our capital M by itself. So if I write this a little bit better, I have capital M is equal to F D squared over capital G lowercase m. And this is my answer solved. That's my equation solved for capital M. Now remember, you might want to do this if you were using these formulas over and over and over and over again, and you were constantly having to plug in for F, capital G, lowercase m, and D squared. And then if you plugged it into this formula, you would have to do the algebra every single time. Whereas if you did the algebra one time, then you wouldn't have to do it every time you needed to plug in new numbers. That's when we use this, well, quite a bit. Okay. Now this next problem is the same kind, but it is more difficult. I want to get x by itself. What makes this one more difficult is, first of all, that I have it in an x in two different spots, but mainly because I have an addition and subtraction in here, and I did not have that at all up here. This is y over 1, and so I do have one fraction equal to another, and I can cross multiply. When I cross multiply, I need to remember that these are units, so I would need to distribute. So I have y times a minus x is equal to, just for the pattern, I'll put the 1 times x plus z. Okay, now I have x's on both sides, and if these were just numbers, you wouldn't have any trouble recognizing that you need to distribute on both sides. If I distribute right here, I get ya minus, let's just say xy. Yx doesn't matter, is equal to, distribute the 1, or, it doesn't really matter. I have x plus z. Okay, now what I want, since I'm solving for x, is I want my x's on the same side of the equation. So I have an x here and here, and I like positives, so let's say I'm going to add this to this side. I'll write out this step. That will give me ya or ay, whatever you prefer, is equal to x plus xy plus z. Since this does not have an x on it, I want to move this over to here, and I will subtract z from both sides. Okay, so I have ya minus z is equal to x plus xy. Okay, so I have my x's on the same side. If I knew what this number was, I would be able to combine like terms and solve. But I don't know what this number is. Okay, now this is just pattern. I have something like x plus xy. This could be like 2x. Okay, just a number, and we would normally write the number in front. I would be able to combine these if I knew what these numbers were. But I can also factor out an x. So that's what I'm going to do. By factoring out an x, then I will be writing it with only one x in the entire problem. Okay, so I have ya minus z is equal to, if I factor out an x, I get 1 plus y. Okay, if I combined here, this would be my 1, and I was using this as my y when I was talking about pattern. I would do 1 plus y to get 3x, right? That would give me here. If I knew what y was, I would end up with this. Now what would I do here? I would divide by this number. Well, just because I don't know what y is and I can't calculate this number doesn't mean I can't divide by it. So I'm going to divide both sides by 1 plus y. So these cancel out, and then when I rewrite it so it looks better, I have an x alone is equal to ya minus z over, you can drop the parentheses here, 1 plus y. Okay, and this is of course the same thing as ay minus z over y plus 1. You can switch the order of these two easily because it's multiplication. You can switch the order of the addition because that's legal. You just can't put z minus ay because its subtraction order does matter. But this would be the answer to this equation. And this one is much harder than the other stuff we've done.